Good evening, everyone. Welcome to Kubernetes Sri Lanka meetup. Today we have Prithvi and Neelanjan. They are going to do a session about cloud native chaos engineering with Litmus Chaos. Prithvi and Neelanjan, screen is yours.
Hi everyone, hi Chamod, hi Camila. Thanks a lot for organizing this, and we are glad to be here, and we are looking forward to talk to you and present about chaos engineering. So, without any further ado, I would like to share my screen. Is my screen visible?
Yes.
All right, folks. So, as the title suggests, we'll be talking about cloud native chaos engineering with Litmus Chaos, and obviously, Litmus will be introducing the project. We'll be introducing chaos engineering, and before moving on to the agenda, just an introduction about us. My name is Prithvi Raj. I work as a community manager for the Litmus Chaos project at Chaos Native. We started off at My Data, who was the initial sponsor of the project, who started building this project, and will be going to the history as well. But then Chaos Native is solely providing support for Litmus, and then also one of the main sponsors of the project. I also work as a co-organizer at Chaos Carnival and then KCD Bangalore, and organize chaos engineering meetups every last Saturday of the month. And you can connect with me on LinkedIn or Twitter on these following handles. So perhaps Neelanjan, you can introduce yourself.
Thank you so much, Prithvi. So, hello everyone. I'm Neelanjan. I'm a software engineer at Chaos Native and also a contributor as well as co-team member at the Litmus Chaos project. So, I've been contributing to the various causes of chaos engineering, starting with the Litmus Chaos project, such as the GCP VM instance top experiments and a few other different experiments. Thanks.
Thanks, Neelanjan. So moving on, what is the agenda for today? Obviously, you can ask me questions and we'll be taking in midway. But the agenda for today is we'll introduce chaos engineering to you. We'll then obviously talk about Litmus and what exactly has been the journey of Litmus. What are the advantages? Neelanjan will be covering the architecture and the core components, and obviously then we'll have a demo and talk about the roadmap and how you can contribute, because obviously Litmus is an open source project. So before we understand what exactly chaos engineering is, let's understand what is resilience, or what exactly helped coin the term chaos engineering. So resilience, of course, is nothing but this ability of the system to stay afloat or stay still in spite of any sort of outage or a fault happening to the system, or the system going down, and still the system being able to perform in the way it did before the outage is resiliency. But what are the examples of resiliency, and what are the examples of weaknesses? I mean, we are talking about Kubernetes here, so let's take a Kubernetes native example itself. Let's say a pod is evicted from a node. So if the pod is rescheduled and the dependent service is healthy, of course, it's resilient. But let's say the dependent service slows down or turns out to be unhealthy, then of course that's an example of a weakness. And similarly, we'll be like, let's take two more examples. Let's say the node goes to not ready state, or there's a memory leak in a container. So if it's rescheduled and the dependent service is eventually healthy, then of course that signifies that your system is resilient. But let's say it slows down and turns out to be unhealthy, so that clearly signifies your dependent service or your system is showing signs of weakness. And that is what helped us coin the term downtimes or chaos engineering. Obviously downtimes are expensive, as you can see. I mean, Apple or Facebook or Delta Airlines, such big companies have had millions and billions of dollars in form of losses just because of downtimes, or just because their system went down and they were not able to make any repairs in time, or the systems were not tested properly eventually, which led to these downtimes during production. And that is what coined the term chaos engineering. Of course, I mean, you can see such examples, and from the telco sector to the e-commerce sector to the airline sector, everyone is in need of a way of testing which can help them identify possible outages in the future, or possible chaotic conditions that can happen as a real life scenarios, or the downtimes that are possible which could lead to a loss of more than millions of dollars. So that is what brought in chaos engineering. chaos engineering is nothing but the process of testing a system or an infrastructure in production, usually by inducing a fault deliberately into a system, or by inducing deliberate chaotic conditions in the system which might happen in real life scenarios, to understand what are the unexpected disruptions or what are the unexpected scenarios that can happen when that actual outage happens. So the goal of chaos engineering is nothing but to identify weaknesses. I mean, or you call it breaking things on purpose. A lot of people say that when they hear chaos engineering, but it's not just breaking things on purpose, but it's more like you break things on purpose to fix them. That is what chaos engineering is, according to me. And it happens in a controlled manner where you introduce experiments slowly, understand the unpredictable behavior your system might show, and then slowly you keep on testing to make your systems resilient. So we'll move to that. What's the process? But why exactly is chaos engineering required? So this is an example we have taken, or the layers we have taken of an application of Kubernetes native application or cloud native application. So there's your application, of course, that's the top layer. It's in the form of a pyramid. So there's your application, and then there are other applications such as MongoDB, Kafka, TIKV for your databases, or applications attached to your main application. Then there are services, of course, Core DNS, Envoy, Prometheus, helps you monitor. So that's the third layer. And then there are Kubernetes services running alongside, and eventually you have your infrastructure layer. So that is what forms the pyramid of an actual application. And resiliency, or the resiliency of your application, is not just dependent on your application, but the other services running alongside that, or the other components which are part of the infrastructure, as you can see. And the dependency increases when we go deeper, as because the applications are developing day by day. This is a dynamic world, and every other day there's a new feature, there's a new enhancement that you're bringing in. Your applications are growing one by one. The services need the way they can scale them, or they need continuous testing. So that is where we believed in the principle of continuously testing or bringing in chaos first. And obviously too many other applications can affect the resiliency of your service. They often change, they are changing themselves. To constantly validate, we require chaos engineering, or to constantly bring that the factor of keeping your systems afloat. The term chaos engineering came into play, and it was invented back in 2012, 2013 by Netflix, because they wanted to scale their systems. They wanted to understand how they can constantly validate the resiliency of their systems while some sort of a possibility of an outage might occur. So, I mean, again, chaos engineering, obviously, this technology has been used mostly by the SRE principle, SRE persona as of now. And SREs and the DevOps engineers have been focusing on chaos engineering. And it somewhere around the DevOps loop, it comes on the ops side of things. I mean, obviously, their dev tests include unit testing, integration testing, E2A test. However, chaos tests focuses on the ops side, because you monitor, you deploy, and then you operate them. And obviously all of this is, again, has to be done in an automated form, because manual planning and labor exists. But automating such tests help you understand that why chaos engineering is important. And we believe in the chaos first principle, as stated by Adrian Cockcroft. He's again someone famous from the chaos engineering space, part of the AWS team. But again, test your systems. Why wait for the systems to go down? Test them repeatedly so that you can already understand what exactly might go wrong. So what are the 4 simple steps of practicing chaos? This is taken from the principles of chaos. I'll go to that link. But first things first, you understand the steady state of your system. So what is the steady state? How does your system behave when it's normal? What is the throughput of the system? What exactly is the system behaving like without any outage? And that is what is the steady state system of your system. And then you hypothesize around it. You create a hypothesis, build a hypothesis on how does the system behave when it's in the steady state, and how the system might behave when real world events might happen. So you vary your real world events, you find out what are the possible real world events that can happen, and then you build a hypothesis around it, so that helps you run your experiment. So once your hypothesis is ready, you start experimenting, you create these experiments, and then you basically curate a chaos workflow maybe, or a suite of experiments which are applicable to your application, and then you start running these chaos tests. You keep on testing your system with different tests. I'll move to the principles, but before that, I think let's take a look at how your systems build resilience. What exactly happens when your system are building resilience? So the first thing is you obviously identify the steady state conditions, and you introduce a fault. Let's say a pod delete, or a pod memory hog, or a pod CPU hog. And once your fault is introduced, are the steady state conditions regained? If yes, of course, your system is resilient for that particular fault, but you need to keep testing. So you inject a new fault there, you inject another fault, and the loop goes on. This is the flow chart basically. And if a weakness is found, then of course you fix the weakness, and then again you introduce a new fault. So that is how system resiliency is built, or chaos engineering works. Or this is a very small flow chart which explains how chaos engineering is usually induced in your system. But going back, as we talk about it, you adapt. That is the eventual goal. You adapt your systems in such a way that you are able to control your chaos experiments or run them in production without harming your system. So moving on to the principles of chaos engineering, this is an open source website which was, I mean, initially commented, and it talks about what exactly chaos engineering is, and how exactly it's practiced. I mean, chaos engineering in practice is eventually you try to disprove the hypothesis which you have created by looking at the differences that have been created by each and every chaos test that you induce in the system. And obviously there has to be a control group and an experiment group. That is how you experiment, or that is how you learned experimenting. So obviously the last goal is automating your experiments. You automate your experiments to run them continuously, or basically drive both orchestration and analysis. You don't want to make it labor intensive, because that really doesn't help your process. And eventually you minimize the blast radius, because obviously you have to create a short-term negative impact, or you have to get your systems down, but you don't want your systems to go down completely, or you don't want a long-term negative impact on your systems with chaos testing, or having a particular blast radius. So that is where the eventual goal is, to adapt. And that is how you adapt, by automating your experiments, running your experiments continuously, and minimizing your blast radius. So moving on, I mean, how is it typically done? How is chaos engineering typically practiced as of now? Game days, of course, that's the main way, or that's the best way chaos engineering is done today. So particular companies or enterprises, they are running game days by running chaos tests specific to their application, or a particular day where different chaos tests are run according to their application needs, to find out, or to build a white paper or a working paper where they can jot down what exactly went wrong, what are the findings from these tests, and how the application behaves. It's rarely integrated into the CI/CD as of now, but the personal belief is that chaos engineering is not just meant for a particular persona, or just testing in production. You can test anywhere. You can test in your staging environment, in your CI/CD, and you need to test your CI/CD. So chaos engineering needs to shift from the SRE persona to the developer persona. As of now, only SREs were thought of using chaos, or chaos engineering was just meant for SREs. But slowly being part of the community since the last 1.5 years, it's been found that even developers are engaging into the chaos engineering, where each developer is requiring some sort of chaos test to make their application resilient while developing. Obviously manual planning and execution exists, and there's senior SRE or director of SRE, or some sort of persona who's involved in manual planning and execution. But automating these tests and involving teams is very important. And obviously observability is not a commodity. You need to observe what is happening in your system. You need to observe that, where is your system is going down, where the chaos test is occurring, or where the chaos is being induced. So all these things are obviously the typical way of doing it, is still helps us conclude the fact that people are reluctant to induce chaos or bring chaos as engineering in their roadmap, or run chaos tests repeatedly. But that reluctancy is slowly shifting with the change. I mean, game days are happening more and more. CI/CD, people are wanting to induce chaos, or big enterprises are wanting to induce chaos in all parts of development. It may be staging, pre-production, production, or from the SRE persona, it's shifting, and observability is key. Datadog, Prometheus, Grafana, I mean, Cloud Foundry, they are looking towards various ways of getting observability into place. So this brings us to Litmus Chaos. What exactly is Litmus Chaos? Litmus Chaos, as you know, I mean, it's a tool set, it's a framework, part of the CNCF Cloud Native Computing Foundation sandbox pool. Hopefully, gets into incubation soon. But it's an open source cloud native project meant to induce chaos. Initially, its mission was to just help Kubernetes SREs and developers to find weaknesses, but now with the community growing and with so much happening around the world, the focus of Litmus is to run chaos for Kubernetes as well as non-Kubernetes environments, and provide a complete chaos engineering framework to help your systems be resilient, or run chaos tests repeatedly and get your systems to be resilient and prevent an outage. So this is the project status as of now. Obviously, there's been a periodic growth, 50 plus experiments and 200,000 plus installations, somewhere around 500,000 or 477k plus to be exact experiment runs, and obviously there are 900 plus community members. So I'll be sharing some links with you, the GitHub link and the Slack link, where you can join the Slack channel. And as you can see, I mean, chaos engineering, if you see this graph, the periodic growth, the graph around January to October, it was growing slowly, but then since April 2021 or March 2021, you can see that there has been an exponential growth towards the adoption of chaos. So that is what tells us why chaos testing, or Litmus Chaos as a project, has been vital in bringing changes to the community. So where in DevOps you can use, I mean, Litmus, as I mentioned, you can use it in your dev CI pipelines. You can have long running tests going on. You can have them in your staging or pre-staging environment, and then obviously pre-prod and production environment. So that it helps you understand, helps you analyze how your system behaves to certain chaotic conditions, and then you can move it in production eventually. So, what's the journey of Litmus been? Chaos of creation of Chaos Hub. That's the main part. I mean, Chaos Hub, as you can see my screen, it's a marketplace. It's a marketplace which helps you get your chaos tests, or which helps you pick what sort of chaos tests you require, which helps you take the experiments which have already been created by the community. You can see pod delete, pod cpu hog. There are container based experiments, and there are Azure based, AWS, VMware, GCP. I mean, you name it and you have most of the experiments. Obviously not all, there are so many more experiments that can be contributed or created, and that is why we came to the Litmus SDK. So the Litmus SDK toolkit helps you create your own chaos experiments. With Litmus, we believe in the BYOC, or bring your own chaos idea, where, let's say you have a chaos experiment which is specific to your application. It could be a Redis application, or Jenkins based, or anything. And that is where you want to induce chaos. So you can write your own chaos experiment and use it with Litmus. So that actually helps you have a better chaos engineering idea, or better chaos journey, and you can contribute it to the Chaos Hub. It's open source, of course, so we invite everyone to contribute. There's a community, and everyone can contribute in. There were CRDs, or custom resources, that were created, operator, scheduler, which helps you schedule your chaos experiments. And then each and every individual was able to inject chaos into their systems via individual experiments. That was the journey of Litmus 1.x, or the older version, which is obviously out there now as well. don't feel that it's not out there. But with 2.0, which came out recently, where we decided that we need to focus more on the user base, or we need to focus more on the community, what exactly the community wants. Obviously, there were features of 1.x, but then we believe that that it's also necessary for us to create something which helps you add chaos workflows. So what chaos workflows are? Nothing but you are allowed to run multiple chaos experiments according to your test suite. You can run them in series or parallel. It helps you. I mean, there's user management and teaming. Why just an individual run chaos? Why not the whole team? You have a team of people, and then you're able to run chaos alongside that. And similarly, there were so many more capabilities or enhancements which help the community grow, which help understand that chaos engineering is not just about running chaos tests or making your systems resilient, but it's also about visualizing what is happening, monitoring, calculating the resiliency of your system, managing workflows using GitOps. I mean, GitOps is something which is coming up in such a big way, and it helps you scale your system, it helps you manage your systems in a particular way. So all this became the journey of Litmus and has come up with certain developments happening in the chaos engineering space. So with this, perhaps we can take some questions, and then I'll hand it over to Neelanjan. So I think we can take some questions. I hope as of now the session has been going well.
Yes. Guys, if you have a question, please drop them in the comment section.
Sure, I think we can answer them in the comment section, and I can share some links with Jamod for sharing them
Yeah.
on the YouTube live. Yeah. So thanks, guys. I'll stop sharing, and perhaps Neelanjan can take it forward.
Sure, Prithvi. Thank you so much. Let me just share my screen. Okay, I hope my screen is visible.
Yeah.
Okay, thanks. All right. Thank you so much, Prithvi. So let's head ahead with architecture overview of Litmus. So far, you have understood that Litmus as a cloud-native chaos engineering tool has been revolutionary in introducing how teams can collaborate between each other and how it brings new paradigms in which chaos engineering can be applied. But let's first understand that how Litmus achieves what it aspires to do. So over here, we can see the entire architecture of Litmus, and we can say that the entirety of the architecture of Litmus is split into two parts. First one being the chaos control plane, and the second one being chaos execution plane. While there can only be one chaos control plane, there can potentially be infinite number of chaos execution plane, which can be managed from one control plane only. So we'll explore the chaos execution plane in a while, but let's first understand the role of chaos control plane and what it is comprising of. The chaos control plane comprises of mainly the Litmus Chaos Center, an auth server, a MongoDB database, as well as a GraphQL server. So all the user requests or the requests that the users use for interacting with Litmus are carried forward by the Chaos Center. The Chaos Center requests are then passed by the GraphQL server using the MongoDB database, as well as the auth server enables authentication of the requests that are posted from the Litmus Chaos. So once the requests are received by the GraphQL server, they are then forwarded to our chaos execution plane. As the name suggests, chaos execution place is where the actual chaos execution happens. Once the request is forwarded to chaos execution plane, we can see that there are three parts to it. First one being Litmus agent infra, second one being Litmus backend execution infra, and third one being our application understanding, that is our application stack. So the request from the GraphQL server, first of all, goes to Litmus agent infra. The Litmus agent is basically lightweight software that gets installed into our target machines or the target clusters, where it helps to inject the chaos. Where we can say that from the chaos control plane, we are sending what we really need to do or what we really need to inject as part of our chaos, and it is being received by the Litmus agent infra or being more specifically Litmus agent, and it carries on or it injects the chaos into our applications. So as you can see over here, there are multiple parts to Litmus agent infra. First one being workflow controller. A workflow controller is basically what passes the request, or basically what our chaos execution steps consist of, and executes them step after step. We'll have a greater depth and a greater outlook on how workflow controller works inside our demo. Next up being the subscriber. The subscriber is basically the link, or the what we can say broadcasting point, from which the GraphQL server is connected. All the requests that are coming from the GraphQL server are forwarded to the subscriber, which then uses this information to implement the workflows. So that is a bidirectional connection, that is from the subscriber. We also get a few other pieces of information back to our GraphQL server, and eventually in our chaos center, such as the chaos result as well as chaos logs, both of which we'll see in our demo. Apart from this, we also have our concepts of backend GetOps controller, or something known as the GetOps, that we are extensively using in our Litmus, which we'll also see in just a short while. Moving on, we have something known as a chaos monitor, which basically exports the chaos metrics to be observed as part of external observability tools, which can be monitored using tools such as Prometheus as well as Grafana. Moving on, we have our Litmus backend execution infra, where the actual execution of our chaos workflow takes place, that consists of individual chaos experiments as well as individual chaos steps that inject the failure inside our application. It consists of various components such as Chaos Experiment CR as well as Chaos Engine CR, both of which are Kubernetes custom resources that enable the orchestration of chaos for the failure to be injected as well as orchestrated during the chaos duration. Moving on, we have a chaos operator, which is a custom Kubernetes controller that helps us to orchestrate the chaos, and it helps reconcile the state of chaos engine custom resource so that the failure can be injected inside our application stack. So if this all of these details feels a bit too much, please hang on with me. We'll be having a greater in-depth understanding of each one of these things inside our demo. Moving on, let's just have a understanding of the core components of Litmus 2.0. First one being the chaos center, and second one being the chaos agent. So as I had earlier told, that Litmus 2.0 has been very crucial in enabling teams to collaborate on executing chaos together. And for that to be enabled, Chaos Center and Chaos Agent has been two cornerstones that have revolutionized the Litmus Chaos project. The Chaos Center being the web UI as well as the command line interface known as Litmus CTL as well as the Litmus API, using which the users are able to access the Litmus resources as well as perform the chaos experiments. The other part is the chaos agent, which I had just explained. It is a small software which gets installed into our target Kubernetes clusters, using which we inject chaos into our target applications. So we'll also have an understanding of both of these resources inside our demo. Moving on, let us understand how the Chaos Center works. So Chaos Center is responsible for the creation of chaos workflows. It gives us a graphical user interface using which users can create a chaos workflow of this in using a few simple steps. Using this chaos workflows, we can have our chaos experiments, or a set of chaos experiments, which then inject the failure inside our applications. There are multiple ways of workflow creation, such as using predefined workflows or workflow templates, you name it. And then we have also control over experiment editing that allows our experiment steps to be modified in any sequence, namely whether it be parallel or sequential. We can order the steps in the different ways in order to create our unique experiment scenarios or workflow scenarios, which basically represent an actual chaos scenario that we might face in our real life. Moving on, we also have the option of creating single or recurring workflow creation, which allows us to basically run the chaos at different intervals as an automated workflow. And finally, we can also have control over experiment priority, which will be very much required to define the weighted average of basically how much an chaos experiment affects our application under test. Moving on, let us understand how the workflow management works. So, a chaos workflow is nothing but a set of steps, a set of experiments, or a set of steps that help us inject a chaos into our application. But more than just being steps, they help us replicate an actual chaos scenario, an actual real life chaotic scenario that can actually affect our application. In order to make this workflow happen, in order to enhance the features of our workflow, we basically use many different enhancements, such as GetOps, which is very tightly integrated into our Litmus, and it helps automate our workflow runs, serving as a single source of truth, as well as using event tracker policies, which is something that enables us to dynamically allow chaos workflow runs based on the state of our Kubernetes cluster. Moving on, we also have the option of pulling in images from the custom registries, basically public or private, any registry will work with Litmus Chaos, as well as we have the option of analyzing a workflows and workflows resiliency score. A resiliency score is something that tells that how much resilient is our chaos workflow execution, and it allows for a better evaluation of how resilient is our system. Moving on, we have also the concept of multi-tenancy inside Litmus. As the name suggests, multi-tenancy allows multiple users to use the Litmus in a very productive manner. And in order to make this happen, we have our Litmus cluster as well as namespace scope. So this is something that is very much crucial in the chaos engineering space, where the blast radius of our chaos workflows need to be controlled. So with the option of namespace scope, we can actually allow Litmus to only target a specific namespace inside which it can perform the chaos experiments. And contrary to that, we have cluster scope, which allows chaos injection to happen across all the different namespaces present in our cluster. Moving on, we also have our authentication process using which the portal can be accessed. So only the authenticated users can, of course, access our chaos center. Apart from that, we also have role-based access control for our different chaos experiments, so that we can only allow a minimal set of access control or permissions in order for the cluster to be accessed, so that the experiment can leverage those permissions and perform its chaos injection on the application. Finally, we also have the concept of teams, which allows the different set of users to access the Litmus in different ways. So over here in the flow diagram, you can see that we have three sets of users. First one being owner, second one being editor, and the last one is viewer. So as the name suggests, each set has its own set of permissions, but decreasingly less set of permissions available to the viewer, with the viewer being only able to view the chaos workflows as well as the different metrics generated as part of chaos workflow, all the way up to owner, who will be able to add new members to the team as well as perform chaos experiments and leverage the total functionalities of Litmus. Moving on, we have our monitoring and observability suite, which is inbuilt inside the Litmus. So as Prithvi was explaining earlier, observability is not right now regarded as a common commodity. Rather, it is built as separate pieces that are particular to the what we can say applications that we are using. But Litmus provides a centralized data source or centralized dashboard that basically helps us to monitor the chaos in real time and much more. So first of all, of course, we can connect a data source to it. It can be any data source such as the Prometheus data store or like Datadog, you name it. Then we have our visualized workflow runs. So as soon as we run our chaos workflows, we'll be able to visualize them into the real time that we'll see in the demo in a short while. Then we have comparison of workflows, so that we can actually compare that how a workflows run is significantly different from a different workflow run. Moving on, we also have our option of creating our own dashboard as well as tuning them to make sure that we only have the information that is most relevant to our observability use case, and we can tune our workflow dashboard to monitor this chaos metrics in the real time. This all is part of the inbuilt options inside our Litmus, which we'll see in a short while. Moving on, the much awaited feature that was added as part of Litmus 2.0, that is GetOps. So GetOps is something that has been reimagined in case of Litmus Chaos to help automate chaos with Litmus Chaos. So basically, it has twofold approach. First one is get as single source of truth. So it allows the chaos workflows that are run as part of Litmus Chaos to be stored directly inside our Git database. So we use Git as a database to store our chaos workflows, so that if we make any changes to the chaos workflow, it takes place inside our Git, and only that workflow gets run when we are trying to pull and run a chaos workflow. Moving on, we also have tracks events and trigger chaos events. So we have something known as event tracker policies inside Litmus, which basically observes the current state of our cluster, of our target cluster, and if the state defined inside our event tracker policy matches to that of our current state of our cluster, basically a chaos workflow gets triggered, and the chaos injection takes place inside our target applications. So that's GitOps for chaos that we have implemented as part of Litmus Chaos. Last but not the least, we have a non-Kubernetes chaos inside our Litmus Chaos as well. So non-Kubernetes chaos, as the name suggests, refers to the chaos use cases that are not particular to the Kubernetes. These allow us to target different public cloud as well as bare metal targets such as AWS, GCP, Microsoft Azure, or VMware. So non-Kubernetes chaos is a definite must to have with Litmus, because of more than often we have observed that although all the businesses right now aspire to be a cloud native in the technology stack, but that is rarely the case. Most often they are a hybrid mix, having cloud native services such as Kubernetes, as well as having some part of their traditional infrastructure stack, let's say in VMware, or having their bare metal servers, as well as they have their own public cloud VMs running. So we feel that as Litmus Chaos aspires to be the only chaos engineering tool that you would ever need in order to inject chaos on all your different targets across your entire business use case. So we also allow Litmus to target these non-Kubernetes entities in order to perform chaos engineering as a part of your single chaos workflow. So moving on, we have our inject chaos on infra resources, such as we can target different resources such as VMs, disks, or other kind of resources as part of your public cloud, such as AWS, GCP, Azure, or VMware. Moving on, we also can attack on bare metal nodes, such as IPMI based out of band access, like bare metal nodes that we enable using the Redfish API. So that is something worth making Litmus a standardized chaos tool for all your different chaos use cases across your business. So to summarize, what are the advantages of Litmus 2.0? We are proud to have our chaos center in place, which is the single user front facing component that allows all the requests for the user for the chaos to be implemented inside our target applications. So that's what chaos center is. Then we have the support for chaos agent, which allows us to target multiple chaos chaos applications, or like applications in which the chaos is to be injected from the single chaos control chaos center. Then we have also curated the chaos workflows according to specific scenarios, that the workflow creation steps that I'll show you in just a short while. Then we also have something known as Chaos Hub, as Prithvi was discussing. This is an open marketplace for all the different chaos experiments that are created for Litmus. Next, we also have a Litmus SDK that implements the bring your own chaos principle that allows the users to develop chaos experiments in Python, Golang, as well as Ansible. Moving on, we have the support for GitOps, as I just explained. Then we also have very much required multi-tenancy for multiple users to access Litmus. Then we also have the inbuilt observability tools inside Litmus. And finally, we can also perform non-Kubernetes chaos using Litmus only. Moving on, let's do a quick feature comparison between 1.x and 2.0. So earlier we had experiments, and we were allowing these experiments to be run as only one user per cluster. That is, we can only target one single cluster using our own experiments. And we only had a public chaos hub to be supported as part of Litmus. And there is CLI only support. That is, there was no web GUI or any API that we are exposing as part of Litmus. But come Litmus 2.0, everything has changed. We have our chaos workflows that allows us to build complex chaos scenarios that are modeled after the real life chaos scenarios that can happen anytime. We also have multi-tenant support that allows teams to collaborate with each other very well. Then we have our cross cloud integration across per organization. As I'd explained, we can go for public clouds or private clouds across GCP, Azure, you name it. Then we can also have our public and private chaos hubs, which allows teams to potentially develop their own chaos experiments as well as test them out using their private repos. Finally, we also have the support for CLI and GUI right now, as well as the Litmus API. And we also support GetOps, as well as the focus right now is on scalability. That is how we can make sure that our Litmus is more scalable and more integrable with an interleaved monitoring system as well. So, so far we have explored Litmus in a lot depth, and if there are any questions, I'd like to take some before
We
we
have a
move on to
couple
the
of
demo.
questions.
Sure, please come on.
So Kanchan is asking, what is the main reason for choosing GraphQA?
Okay, so GraphQL server is something that basically allows us to have a link between the requests that are being received from our chaos center and then serve those requests. So there is not any particular advantage of using GraphQL, but it is rather a set of conscious business decisions which allows us to have faster integration, or we can say faster processing, or we can see a better optimized schema over the REST API. So those are a few very much, we can see, in-depth considerations from the architecture point of view.
Okay. We have another question from Chiranga. He's
Sure.
asking, do we have plans to introduce JVM level chaos experiment? If yes, when will they be available?
All right. So as
Yes,
per
Chiranga. I can take it up. Yes, we are planning to introduce JVM level chaos as well as IO chaos, HTTP chaos. All these are in the pipeline, and moving forward post 2.0, the idea is to have mostly increase the amount of experiments in the chaos hub, or gain more and more contributions in the chaos hub, and increase the experiment pool. So as of now, obviously, I think a couple of chaos experiments are due, and you can see them in the upcoming releases. But yes, JVM level chaos is planned, and by the end of Q3 or Q4, hopefully we'll have JVM chaos.
Yeah, so I guess Kanchana has a question, and performance was
So,
okay. Sorry, I quite didn't get your question, Kanchana. Can you please rephrase your question? Okay, all right. So, okay, so it is a follow-up question from before. Yeah, right. So, yes, we have actually implemented GraphQL using Golang over here. So, the performance was definitely good, we can say. And basically, it is the improvised schema that we use with the GraphQL server that allows it to integrate better with our other cloud native services, we can say. So, we, as if you'll go to the basically the architecture stack, we also have our own auth server that is also running in uh, GraphQL actually, and then we have yeah. So, and we also have our MongoDB that is as part of our our database that we are primarily using for all our services. So it definitely integrates well with all the other components in our technology stack. So therefore, we opt out to use GraphQL. Hope that answers your question, Kanchan. All right, so I guess that's it with the questions. So we are free to move on with the demo. All right. So for the demo, we have something interesting for you. So let us imagine that we have an e-commerce application, and let's say it is Amazon or any other e-commerce application that you're trying to buy your goods on. So what is happening is right now it is, let's say, a sale, and there are multiple users all across the country or even, let's say, world, that are trying to access your services or your website. Now potentially it creates a, what we can say, a service outage usually. So that is something definitely we don't want to happen, because that would incur a lot much of hefty cost for the businesses. So we'll just illustrate that how Litmus can simulate such a chaos scenario, and how it basically helps us to mitigate this kind of situations. So for this demo, I have a demo e-commerce application for you. It is known as sock shop application, and it is basically, you can say, a demo application for an e-commerce application for buying socks. So it is just a simple application where you can see the different types of socks that are available to buy. I can also view the catalog that we have over here, and over here you can see that there are different types of socks that we can choose from. So what we are trying to do over here is that this is a microservices based application. So I'll try to target these particular catalog pod that we are running over here. And upon doing so, we'll check whether this application deployment is resilient or not against our chaos. So as soon as the pod delete happens, what will happen is the pod that is enabling this catalog to be displayed to us, that will potentially be rendered useless, and we won't be able to access it since it will be deleted, and it won't be accessible over here. So let us see how do we do it. But before that, let me just show you that how our chaos how the installation of Litmus looks like inside my Kubernetes cluster. So I can say kubectl get all dash in Litmus. So this will get us all the resources that are installed in the Litmus namespace as part of our of our Litmus installation. We can see that we have different pieces of components over here, such as the chaos exporter, we have the chaos operator, we have the event tracker, we have the front end Litmus front end web UI that we were just seeing, then the backend server, then we also have our MongoDB database, as well as the subscriber, as we had discussed earlier, and the workflow controller that basically enables our chaos workflows to be run as part of this chaos injection. Then we have also a couple of services that we have exposed over here to basically access these pods. And then we have deployments which form these pods, and so on and so forth. So we also have a few stateful set for our Mongo. So this is how the Litmus gets installed. I mean, this is all that is needed to run the Litmus. And I should probably mention that you can install all of these from a single command, and Prithvi will be shortly sharing the links of the docs that you can follow. Basically, there we have the details of how to install Litmus as well. Moving on, I'd like to show you the demo microservices application as well, that is the sock shop, how it looks. So I'll say kubectl get all as an sock shop. So over here, we'll be able to see all the different components that are installed as part of our sock shop. And yeah. So as you can see, it has different parts, such as we have our deployment, our separate deployment for carts. We have our separate deployment for catalog, for our front end, for our orders, for our payments, different microservices running. So we are trying to target these catalog actually. So you can, over here, you can see in this catalog pod, we have only 1 out of 1 pod available right now. So what we expect to happen is that upon the chaos injection, this one single available pod will actually go down, and we'll be able to see that 0 out of 1 pod is available. And the chaos injection will cause the catalog to be disappear. That is, we won't anymore be able to access this catalog of the socks. So let us hop right into our chaos center and see how we can perform a chaos experiment or a chaos workflow in this case. So we can directly go to our schedule workflow. Upon scheduling a workflow, we'll be asked about to select an agent. So we have two types of agent in Litmus. First is the self agent, and another one is the external agent. A self agent allows us to inject chaos into the same cluster in which our Litmus control plane is installed. That is, basically we are targeting the same cluster in which our Litmus is right now installed. And we also have our external agent, which would allow us to inject chaos into any other external cluster that we are attaching to it. So right now we only have our self agent, so we'll go ahead with it. And over here we can basically choose from how we can specify our workflow. So we have too many options. For example, we can choose one of the predefined workflow templates, which are basically good for day zero users who are new to Litmus and want to understand how workflow will work. But over here, I'm here with you to guide you through a more advanced step, that is how to define your own workflow templates and how to basically create your own workflows. You can also select your chaos. You can also create your chaos workflow using your chaos hub. So as Prithvi was showing you earlier, all the experiments that are available as part of your chaos hub, but instead we'll actually import a workflow YAML in order to perform this experiment. So I have already defined my chaos workflow inside a workflow YAML file, which I'll be using right now to schedule my chaos. So I'll just go next and I'll name this sock shop workflow. And we'll go to next. And over here, you can see that my experiment steps are already defined. So over here, we can see that we have only one chaos experiment as part of this workflow, that is the pod delete experiments. We can also define multiple experiments that can be basically added in any order, be it sequentially one after the another, or we can also parallelly add them so that they take place in the single step. All of that is possible on from using the chaos workflows. So this is how a chaos workflow looks like, and I'll also show you the manifest using which I created this workflow. But let us first understand that how this pod delete is going to work. So if we go to the settings of our pod delete experiment, we can see that we have a catalog pod delete. We have defined the experiment name, that is catalog pod delete. And next we can see over here, it is basically going to target our application namespace, that is the sock shop namespace. So as you might have guessed, this is a cluster wide installation of Litmus Chaos, and that allows us to target the application in other namespaces as well. So we are targeting the sock shop namespace right now. Inside that, we are targeting a deployment that has an app label of name is equal to catalog. So if I just quickly go back to my terminal, and if I say kubectl get deployments dash show labels dash and sock shop, we'll be able to see the deployments that are inside the sock shop as well as their labels. So over here inside the catalog, you can see that we have a label of name is equal to catalog. So I am using this label in order to, okay, sorry, I've just, yeah. So I'm using this name is equal to catalog to basically specify that I want to inject chaos inside my catalog pod. Once we are done, we are also setting job cleanup policy as retain, which would allow us to basically inspect the chaos logs that are generated during the chaos experiment. So we'll go to next. And right now we have also defined a probe. So what is a probe? A probe is basically defining a check, basically a condition that we are defining that is being validated by the experiment pod during the execution of our experiment. So we have different types of probes over here, such as the HTTP probe, CMD probe, PROM probe, to name a few. So over here, as you can see, we have defined a HTTP probe. An HTTP probe is basically used for checking whether an HTTP request is getting accessed or not. So if I just go to details, you'll see that I'm trying to reach out to this particular URL. And if I go to this URL, you will see that we get an API output. So this is basically the catalog output that is enabling our this page to appear. So this is the API that enables this page to be populated, or basically these uh, cards or like the catalog to be updated. So that is why I'm checking the URL for this using this URL. And then we are also setting a response timeout, that is the time till which the check should go on, before after which it flags the experiment. And we are also defining a method. So we are saying that put a get request at this URL and check if the criteria is 200 or not, that is the response status code is 200 or not. So if it is 200, then of course the URL is accessible. If we are not getting 200, then of course it is not accessible. So this probe will allow us to see that, okay, whether we are really able to access our experiment pod or not, the catalog pod. We go to next, and over here we have a few different experiment tunables, such as the total chaos duration, which will define that till how long we should continue our pod delete. Then the chaos interval, which is especially helpful if we are deleting multiple pods, which will allow us to separate out the timing between the pod different deletion of our pods. So that's it for our tunables and our application. I'll just put finish over here. And just to show you that what is the document that I had initially used for creating this YAML, I'll go to edit YAML. And over here, you can see the different steps of the experiment that we're trying to follow over here. So first step is, of course, install the chaos experiment that allows all the pod delete experiment to be installed as part of our chaos workflow execution. And then the actual step of our pod delete experiment. So if we go into our pod delete experiment, you can see our chaos engine for our pod delete is defined over here, and all the different information that we had seen earlier, including the HTTP probe, including our chaos duration, chaos interval, are already defined for here. So that is basically what we are trying to do from the web UI as well, to build this workflow. And in fact, this document is what is going to our chaos execution plane as during our execution of our chaos. So without any further ado, let's go on and execute this chaos. So we can also have our resiliency score defined. So we can attach some weights to it. So these weights basically allow us to fetch a weighted average during the resiliency score calculation. So since we have only one chaos experiment over here, so it doesn't really matter what I put over here. So I'll keep it as 10, since the weighted average will be anyway 100%. So after that, we can schedule the chaos right now, or we can create a recurring schedule as part of a cron execution, but we'll schedule it right now. We'll go next. And finally, we are all ready. We can finally see all the details over here. And once we are satisfied, we'll click finish. Upon clicking finish, right now our workflow is actually scheduled, and we can go to our workflow to see it live that while it is executing. If we go to our workflow execution, we can see the different steps of our experiment getting executed in real time. And this is the workflow execution graph, where we can inspect the different steps of our chaos workflow execution as they proceed. But this is not only the part of observability that that Litmus provides. We also have our inbuilt observability dashboard, which I'll show you in a while, as well as I have a Grafana dashboard, which allows the observability, external observability, including using a Prometheus data store. So we'll inspect that as well as soon as the chaos starts. So right now what is happening is that, first of all, the pod delete experiment got installed as part of this step. Once the experiment is installed, right now we are in the step of executing our pod delete experiment. That is, we are deleting the catalog pod right now. So as we had discussed earlier, this would cause our catalog to be rendered to not be rendered. That is, we won't be able to access our catalog. So if I just refresh my page, as you can see, right now our catalog is not getting accessed. So this is what is happening because of our chaos injection. And I can show you this behavior using our inbuilt observability tool as well. So you can see this is our dashboard using which we can access our observability dashboards. So you can see I have defined our dashboards for different metrics. First is the order queries per second. This is for the order pod that we had seen so far. This is for the catalog pod in which we are in which we are interested, and then we have the carts pod. So of course we can select only those dashboards that we really require as part of this observability. And as you can see, while all the other pods are relatively stable and there is not much change into them regarding their status, you can see over here that catalog queries per second have drastically gone down over here. And this is because of the fact that the pod experiment pod has actually been deleted, as we had confirmed from this from our web UI as well. As a further check, we can actually go inside our terminal, and uh, I can again use the same command. And you can see over here right now that our catalog pod has reduced to 0 by 1. That is 0 out of 1 pods is right now scheduled. We can further confirm this behavior as using our external observability tool. So I have our Grafana over here. So if I select the chaos over here, you can see that again we have our orders queries per second, we have our payment queries per second, shipping, everything is working fine. But catalog queries per second, we can see that drastically the queries per second is dropping since the pod is right now deleted. And in fact, there is no queries that are accessible right now since the pod is itself is deleted. So no metrics can be fetched as part of this pod. So right now the chaos is still continuing, as we can confirm from our observability mm, from our observability dashboards, and we can also refresh it from here. So it will go on for the total chaos duration, actually for the 30 minutes, 30 seconds, excuse me. And we can again go back to our running workflow. So yeah, so during this check, as you can already understand, since the catalog is not really accessible, this would cause the HTTP probe that we had defined earlier that checks whether the catalog is accessible or not to fail. And this should actually result in the failure of this experiment, since we had defined it, the condition to pass is basically it should get a response status code as 200. But since the URL is down right now, the API is down, so of course it won't get a 200. So we can confirm this behavior over here. If we wait for some more time, we can see the probes and the chaos result get populated over here. So meanwhile, if we have any questions, I'd like to take some. Okay, guess we don't have any questions, so we can wait for a while to get finished with this experiment. So as you can see, as part of our chaos observability, we also have logs. Okay, so yeah, logs are right now populated. As we can see, the this experiment has actually failed, as indicated our chaos workflow. And if we inspect our logs, we can see the different steps using which the chaos experiment has followed. But I will just directly skip to our chaos result, which is basically a summarization of our chaos experiment run. So as you can see over here, we can see that experiment status phase is completed, but our verdict is failed. That is, the experiment has failed. And why it has failed? Because our probe success percentage is right now 0. That is, our HTTP probe that we had defined didn't pass, and it says that better luck next time. So of course there is only one failed run right now because this failed. So that is how the chaos works. Oh, by the way, like right now, since the chaos is over, the pod is again accessible right now. We can confirm this behavior by refreshing the page. As you can see, everything is again accessible. And over here, we can see that everything is right now again in proper. The queries per second is rising, and we can see detailed information, that is probe success percentage is 0, verdict is fail, all the different type of annotations that are coming through our Grafana dashboard. So that's the conclusion of our demo. Let me uh, discuss a few future roadmap that we have for Litmus Chaos. So we plan on having an increased support for Chaos for non-Kubernetes infrastructure components. Currently, we have a steady set of experiments for AWS, GCP, Azure, but we are planning to expand on our VMware suite of experiment, which will greatly enable the organizations to test their bare metal infrastructure. Then we also have more planned for more application specific chaos experiment with native faults and health checks, including more types of proofs, including more types of experiments, diversifying our types of faults. So that is something to look up to. Next, we have improved Chaos SDK for creation of user-defined experiments. So as of now, as I told, we have a Go SDK, as well as we have a Python SDK, as well as Ansible SDK. So all these SDKs basically allow the developer to develop their Chaos logic into any language of their choice and integrate it using Litmus. Fine. Again, we have additional probe types, as I explained, for our state hypothesis validation. And we are also looking forward to having some improved observability for our chaos experiments. That includes including more types of data stores, as well as diversifying our inbuilt chaos observability dashboard. And finally, we are also planning to have more types of chaos, as Prithvi was explaining. We are going for HTTP chaos. We are going for VM. We are going for more application level chaos, including JVM chaos, IOT chaos, you name it. So yeah, that is something definitely to look up to in the further releases of Litmus. Finally, a few contributing guides. So of course, you can contribute to any issue you like. We have our GitHub link that Prithvi will be sharing soon. You can track the good first issues, which are really great for the different folks who are new to this cloud native or Litmus plane. And there are various links that you can basically check out from here. So we also have a few links of our docs and codes, etc. So you can definitely would like to join our Slack channel. The link is here. Please join us. We have a thriving community of 900 plus members. We'll be very happy to have you. So yes, that's it for this session. Thank you so much. And if you have any questions, please. Okay, I guess no questions. Prithvi, would you like to add something to it? Okay, is Prithvi not here? All right. All right. Thank you so much, guys. Thanks, Kanchanan. Thank you, everyone, for joining. Thank you so much, Kubernetes Sri Lanka, to allow us to join for this wonderful webinar. It was a great time joining you guys and sharing the insights from Litmus. So thank you, everyone. Over to you, Kamod.
Thanks, Neelanjan. Thank you so much, Prithvi and Neelanjan, sharing your knowledge with us. And thanks for everyone who joined today's webinar. See you next time. Bye.
Bye, everyone.